Welcome to Carlton's Math Corner. Today we're going to discuss linear equations. At this time, please make sure that you have your math journal, your vocab packet, as well as something to write with. Today our target is I can determine if a table, graph, or equation represents a linear equation. Well, a linear equation, if you notice within the word linear, it has the word line. So a linear equation is an equation that creates a line. And so y equals 2x plus 3, that's an example of a linear equation. It looks very similar to when we worked with functions, where we plug in a number and it spit out an answer. Well, very similar to that in the fact that linear equations, the reason why they're a straight line is because they rise and they run at a constant rate of change. And we'll talk further about what that means in just a moment. So this number right here on the end that's being added on, or sometimes there's a number that's subtracted from, that number is called a constant. Okay, so let's look at an example. First of all, let's look at a table as well as a graph that goes along with it. The first example, this is a linear example. All these numbers have been plugged into an equation, and these are the answers. So this is the range that came out. So -2, -3 would be my first ordered pair. So if I go left 2 and down 3, I would plot a point. -1, -1, that means left 1, down 1, and I plot a point. Once I plot all these ordered pairs, look what kind of line is created. This is an example of a linear equation because it creates a straight line. Now the straight line can be diagonal, it can be horizontal, it can be vertical, as long as it's straight. Okay? Now look at this example down here. This is an example of a non-linear equation because these numbers were plugged in: 0, +1, -1, +2, -2, +3, -3, etc. These were all plugged in, and these are the answers that came out, or the outputs that came out. And so the first ordered pair would be +1, +1, then -1, +1. Do you notice that no matter if I plug in a +1 or a -1, I get a +1 answer? Now when that happens, what happens is it creates a graph that looks like this. And this is a nonlinear graph because it's got a curve to it. And this kind of graph that creates like a U shape is called a parabola. And it is put in that category as nonlinear because we don't have a straight line. Okay, let's look at two more examples. Here's an example, a linear equation, and this is a nonlinear equation. What do you notice? Yes, I hope that you notice that over on the linear equation, there is a constant rate of change, meaning this, on the range side, it's going up by 4s. On the domain side, it's going up by 1s. And so what we say is that this equation is rising 4 and it's running 1. Okay. Now down here, do you notice that there is no constant rate of change? It's all over the place. Rising 1, then rising 0, then rising 3. I mean, it's all over. And we call that a nonlinear equation. Okay, so when we're looking at tables, we're looking for a constant rate of change, something that has the same change from one ordered pair to another. Okay? Okay, so here's another example. These are the equations that we started with, and this one is referred to as a linear, and this one is a nonlinear. Why? Okay, so we start off with the equation and we plugged in actually the same exact numbers. So same numbers we plugged in just to keep that constant to see if we would get a constant change in the end. And so we plugged in -1, 10 times -1 plus 8, and we get -2. 10 times 0 plus 8 is 8. What are these numbers going up by? What's the constant change? Exactly. They're all going up by 10. And these are going up by 1 because those were the numbers that were chosen. Okay. Over on this side, these numbers are going up by 1, but watch what happens. If I put a -1 in here, -1 squared is -1 times -1. So that's +1 times 3. 3 minus 2 is 1. Put in a 0, we get -2. Put in a 1. Do you notice that we still get a 1 as an answer? When we start having repeats of the same number, then the rate of change does not stay the same. If you look at this, this does go about by 1, but look what happens once these two started to repeat. If I start with -2 and I subtract 1, I'm just trying to see the difference between them. How much did they change? -2 minus 1 is -3. 1 minus a -2 is a +3. And then 10 minus 1 is 9. All of those differences are different. So that does not fit in our definition of a linear equation. A linear equation needs to have that constant rate of change, and these are not constantly changing the same. And so this is put in the non-linear category. If you look at these graphs, if we're looking for linear equations, we're just looking for straight lines, okay? And there are 3 graphs that have a straight line. This one, and this one. Those are considered linear. The other 2 are non-linear. Just because when we see a straight line, that means we plug in one number and we get one answer out. Okay? And it is falling in the category that it is rising, and running at the same rate of change. So it's rising, running, rising, running. And same thing over here, straight line. Rising, running, rising, running. It is always at the same rate of change. Now with a curved line, it's not. Like this one is rising and running, rising and running, but then it starts to change down here because if I rise and I run, it's not going to hit the exact same spot. It's got to be, the rise and the run has to be exactly the same throughout the whole line. And that's why we get this curve, because it's not change, it doesn't have the same rate of change. Okay? What I would like you to do is I want you to try these out. I want you to tell me, are they linear or non-linear? And for some of them, you may have to graph them, or maybe you have to create a table of ordered pairs just to see if it's linear or not. Maybe you have to do both, graph and create a table. But I want you to tell me, are these considered linear or non-linear? Okay? Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.